Hi, everyone, and welcome to the Target 25 Part 1 homework review. And one thing you'll notice, well, I just got to shut this window. One thing you'll notice is since this was a fairly short worksheet, and since all of these things, as far as visualizing bases and dealing with bases are concerned, are so important, you'll notice that basically this review is the whole worksheet. And so if you feel great about it, awesome. If you don't, hopefully this video will help catch you up and help you start to feel better about these skills and about, progressing from Unit 8 into Unit 9. As always, if not, please jump into our Google Hangouts or send me an email and I'll absolutely help you out. But let's walk through these problems and let's start to feel good about them. So remember, what we're doing here in every single one of these problems is simply just looking at our solid, drawing the base of our solid, figuring out the perimeter of that base, and figuring out the area of that base. And there's really no like straightforward way because the base changes every time. And what I mean by that is sometimes it's a triangle, sometimes a circle, sometimes a rectangle, sometimes some other shape. And so you just have to know some things about those shapes. And once we decide what shape it is, we do, those things, those formulas, whatever it might be, to figure out this other information. So what we should see in this first one is, and you may or may not know what it's called yet, but we are going to call this a triangular pyramid. Now, it's a pyramid this time, and we'll talk more about this in our other lessons, but it's a pyramid this time because the walls come to a point. The walls come to a point. Every other shape that we've talked about, prism, the walls don't come to one singular point, right? Like if you look down here at this cube looking thing, rectangular prism, there's not one singular point that all the walls converge at. So that's what a prism is. But up here, if we take that bottom to be our base, and remember we name bases by the shape it is, and so we have a triangular base, and then we call it a pyramid because those walls from the sides of the triangle come up and meet at this one point, right? And it kind of just looks like, how we consider pyramids. And so here we go. With that being said, again, we name things by their base, and so it's a pyramid, but it's a triangular pyramid, which means the base has to be a triangle. So I'm going to draw this bottom triangle here over on the side. And I'm going to try to do it just like they did. So, we've got these dotted lines, and then we've got these lines coming down. And we know the right side is 3 feet, but we also see those tick marks. So all the sides are 3 feet. And that's awesome. So we know that, right? Especially for the perimeter. So let's jump over there and do that real quick. Perimeter is just add up all the sides. And so it's just 3 plus 3 plus 3. So our perimeter is 9 and our units are feet. So 9 feet. Now, just like in our lesson, when we had this triangle, to find the area of it, area of a triangle is our base times height divided by 2, right? And so our base, I'm going to consider the base this time to be 3, this top one, but we do not have our height. Remember, our height is an imaginary line coming from one of the tips of our triangle, and it makes a 90-degree angle with what we consider our base. And in an equilateral triangle like this, it cuts that base in half. So each side of it is going to be 1.5, right? And two 1.5s make 3 total, so that's great. But again, each side of it is 1.5, and that up and down line is our h, and we can work with that and the new 1.5 and the fact that that's a right triangle, right? And I'll draw it over here, 1.5, so 3, 1.5, and h. And we can work with that and do the Pythagorean theorem to find h. So we will solve h squared plus 1.5 squared equals 3 squared. Now, let's keep squaring that out. So h squared and 1.5 squared is going to be 2.25, and 3 squared is 9. And then we'll subtract 2.25 from both sides. So h squared is going to equal 6.75. And then to get h, we just square root. And so h is going to equal, and I'll even do this one on the calculator, square root is 6.75. So second square root button, 6.75, enter, and it tells us roughly 2.6 for our height. Our height is 2.6. Now, remember the reason we wanted that was because we're going to plug that into our area formula over here. And so our area will be, and remember we're considering this side of 3 to be our base, so 3, and then times our new height, which is 2.6, and then we divide by 2. And so let's go to our calculator one more time. We need 3 times our height divided by 2, so 3 times, and then instead of 2.6, I'm going to hit up and highlight that number, hit enter one more time. So there's our base times our height, and now we'll divide by 2. And this will be our full area, and it's looking like roughly 3.9. So 3.9, and then feet squared units, right, for area. Now, I would say that that top one is one of the more challenging ones. Triangular bases tend to be fairly challenging. You almost always have to do a little bit more work to get, a height or a base or one of those numbers that's probably missing. Down here, we just need to kind of recognize it, but we'll do a little bit less work in this one and the other one. So in this next one, we'll call this shape a cone. And I think the thing that's most important here is us to realize that the base is a circle again. So a cone has a circle base, and so let's draw that circle. Looks to me like they've given us a diameter, and they're telling us that it is 5. So our diameter is 5, which makes our radius half that. So we'll call that 2.5, right? And now we got to find the perimeter. Remember, the perimeter of a circle is really called the circumference, and the area, or the formula for the circumference, is pi times diameter. So for us to find the perimeter, again, remember in a circle, we call that the circumference. We just do pi times diameter. So pi times 5, and then that'll equal, and in exact form, it would equal 5 pi, and it looks like centimeters is our unit. And then if we type 5 pi into our calculator, that will tell us 15.7 roughly as well. And so we can write the perimeter of this circle as 5 pi centimeters or 15.7 centimeters, whatever one you prefer most, right? All right, and then area, same deal with the circle. We just got to know one of these numbers, and then we have a formula. Area of a formula is pi times radius squared. So we just got to plug our radius in this time, which is 2.5. And so our area is pi times 2.5 squared. And let's type that into our calculator. Pi times 2.5 squared. So I'll clear this. Second pi, parentheses 2.5, and then squared. And our answer is 19.6. 19.6. And that is centimeters squared, square units for area. All right, perfect. Now, the last one. We've got this kind of, I guess it looks like a cube, and we can consider it a cube because all the dimensions are the same, right? But basically, its perfect name would be rectangular prism. Rectangular prism, which means its base is a rectangle. So I'm going to draw the bottom rectangle as the base, and notice it's not really a rectangle, it's really a square, but squares are also rectangles, so we can consider it a rectangular prism for now. And we know that one side's 25, the other's 25. And so perimeter, not so bad then, right? Because in a square or a rectangle, opposite sides are always the same. So if the right is 25, the left is 25. If the bottom's 25, so is the top. Which means for perimeter, we're just going to add all 4 of those sides together. So 25 plus 25 plus 25 plus another 25. And 4 25s is 100. And inches are our units. So 100 inches for the perimeter here. And then area. For a rectangle or a square, we can just consider base times height, right? And so that's just one of the 25s times one of the other 25s. So 25 times 25. And that's going to equal 625. And then this time inches squared for area, square inches every time, or square units every time. All right, and that is the whole gist of part 1. Can we look at a 3-dimensional shape? Can we identify what we think is the base and draw it and find the perimeter and the area? The reason for this, as you will see starting part 2, part 3, part 4, part 5, we're going to be working on finding surface area and volume of these 3-dimensional shapes. And so in order for us to find those things, we're going to need to find perimeter first, area first, and then we use them to take it a step further to figure out surface area and volume and different three-dimensional kind of formulas like that. So thank you very much for your time. Let's move on to part 2 today, and let's have a great day. Thank you very much.